thank you all for coming. Looking at the agenda for the day, it looks like there's going to be a lot of interesting discussion and some good examples, I think, of detail in particular domains, particular areas of certainly the cloud this morning and then virtual worlds this afternoon. What I thought I would do before the more detailed presentations on aspects of the cloud was take a step back and try to challenge or question some of the hype, some of the preconceived ideas about what the cloud might or might not be. So that I'd start by challenging or looking at some of those truths about the cloud, then take a look at the cloud computing stack in a little bit more detail, and then look again at how the cloud might impact upon higher education. But for the first part of the presentation, some truths about the cloud. It's Friday morning. Some of you got up far too early, so I'm going to try to wake you up a little bit and try to get you to think a little bit and see what you think about some of these truths and perceptions of the cloud. So for each of the apparent truths that I'm going to show you, I'd just be interested to know from all of you whether you think it's true or not. And we have to forget for a moment that all these things are a continuum and there's grey rather than black and white. Assume for a moment it's all black and white and it's either true or it's not, and let's see how we do. So this first widely perceived view of the cloud is that it's just about off-premise. It's just about massive data centers at Amazon, Microsoft, and the like. So, over to you. Raise your hands if you think it is just off-premise. Now, for the next question, we'll find out whether you're awake or not. So, it's not just off-premise. It can be on-premise as well. It's interesting, a black or white distinction, and you're going with neither. It has to be one or the other. It has to be either off-premise or... Of course, it's not just about off-premise. There are these massive data centers. This, for example, is Microsoft's new data center in Dublin. But we've heard Ulcc, for example, and a number of others offering smaller, more local hosting. And then you're seeing companies like Cisco and VMware pushing quite actively to apply a lot of cloud computing ideas on-premise in your own data center, applying these notions of virtualization, for example, to gain greater efficiency from the existing infrastructure that you have. Try the next one, see if we get any answers to this one. The cloud is like the electrical grid, apparently. Any takers for that one? No. We'll get you going in a minute. I guess this notion of the cloud being like the electrical grid really came from the writings of Nick Carr, primarily, who back in 2008 wrote this book called The Big Switch. And in that drew all sorts of associations between the rise of national grids and large-scale electrical grids, and suggested that similar things were happening in computing. So this move from every factory having to build their own power supply, having to generate their own electricity before they could actually build the widgets they wanted to build, moving towards electricity being a utility that they could draw upon from someone else who was better able to do that part of the job. And Nick Carr suggested essentially that we were seeing similar trends in IT. And his book was republished in paperback at the beginning of this year, and at that point I took the opportunity to record a podcast with him, digging into some of the detail on his perceptions, and also trying to link it perhaps to some of the trends we were seeing in the economic environment, where we were beginning to see the cloud used as a way of achieving cost savings in IT. Okay. Now, this one really is black or white. It either is or it isn't. So, who thinks the cloud is cheaper than more traditional ways of running IT infrastructure? Okay. Who thinks it's more expensive? Okay. And again, actually, of course, it's not necessarily as clear-cut as it might appear. For elastic jobs, for those jobs that grow with an increase in demand, registration at the start of term, for example, or if you're running a startup, you know, the 2 or 3 hours after your new service appears on TechCrunch or Slashdot, that kind of thing, that kind of elastic growth in computing, the cloud probably is cheaper because you simply buy in the power, the computing that you need at the time you need it. You're not having to have all those servers sitting idle waiting for Slashdot or TechCrunch to notice you. You're not having to have all those servers sitting idle all year waiting for the 2 or 3 days of registration. It's less clear-cut for normal background load, for simply running the email server, for simply running the VLE, for simply running the website on a normal background general load. There are examples that show it is cheaper. There are examples that show it's not. So I think there's some work to do there to dig into that and to understand where the real cost savings, where the real value lies. But for these elastic and periodic jobs, there are certainly clear savings to be found. Another one that should be reasonably black and white. Cloud computing is more green, more environmentally friendly than traditional data centers. Any takers for the cloud being more green? Some. Any takers for less green? Okay. Now again, on the surface, cloud computing and these large cloud data centers should be more efficient. They tend to be sited in areas that make use of cheap, renewable energy sources. A lot of these large data centers from Amazon and Microsoft and the like in North America are being sited places like Washington State and Oregon and making use of cheap hydroelectric power. So it should be more environmentally friendly there, in theory. We're also seeing, for example, the fact that these large buildings full of virtualized servers are running at far higher levels of usage. So there's far less waste, far less idle cycles on those machines. So again, in theory, should be greener. A man called Simon Wardley at a company called Canonical here in London was interviewed recently here and is suggesting that possibly that's not true. He suggests, and there's some work to be done to understand whether it's true or not, but he suggests that human nature means that we are, by our very nature, wasteful. And that if all this cheap, ubiquitous computing is simply available on tap, we'll use it. And we'll use it more because it's easy, because it's cheap, almost free. And so that therefore, although individual units of a cloud computing resource may be cheaper, may be more efficient, may be more green, simply because of the way we are, we'll use more. And so actually, on balance, it ends up less green. And as I say, there's some work to be done to understand that and to understand how you deal with human motivation to deal with that if it's true. There was a recent survey from one of the cloud computing hosting providers called Rackspace, and they asked a number of their customers, do you view cloud computing as a greener alternative to your traditional infrastructure? And they were really pleased at the number of people that said yes. 21%. I actually think that's quite low. I would have expected the answer to be a lot higher, but it wasn't. Cloud computing is unreliable. It's entirely by chance that I picked a Virgin train for that picture. Entirely by chance. So, Is the cloud more unreliable than your existing data center? Any takers for that one? Any data center managers who are going to say, my stuff's better than the cloud? No. Anyone who thinks it's more reliable than your existing infrastructure? That's interesting. The jury's still out, I think. There are some high-profile examples of cloud computing failures. Gmail goes offline for a few hours, for example. But actually, spread out across all the usage of all the servers, it's probably okay. The cloud is insecure. Any takers for that? Or the corollary, the cloud is secure. The cloud is as secure as your existing internal infrastructure. Any takers for that? A few, okay. I think, in the commercial world, it's probably an easier argument to make that the cloud is more secure than local data centers. Where you're a small organization, where the machine room is a cupboard, and your sysadmin is also the person who does a million other things, I think it would be hard to argue that that is any more secure than cloud computing infrastructure. Where the root password is stuck on the post-it note by the machine, and the locked door to the machine room is never closed. Those kind of things. The cloud is certainly far more secure than that. In higher education, where you have trained, dedicated teams and large machine rooms, probably less clear. The cloud isn't less secure, but it's probably unlikely to be more secure. There he is. That's the University of Cambridge's development plan for next year. This is another of those things that comes up again and again and again. Once data is in the cloud, I don't know where it's going to end up. I don't know where the machines are that it's being stored on. Any data I put into the cloud is going to end up in the United States, and then the Patriot Act kicks in, and President Obama can read my email. Yeah, right. There are some cloud providers, certainly, who can't make guarantees for where the data will go. But actually, there are quite a lot who can, and who can say data on a European data center will stay in that European data center and will not go to the United States where the Patriot Act kicks in. Is cloud computing just about Amazon? No, of course not. Amazon is certainly the front runner at the moment in terms of providing this basic cloud computing infrastructure. But there are plenty of others in the game as well. Rackspace, for example, Microsoft, Sun, HP, Google, IBM, and the list goes on. I live in East Yorkshire, and saw a message yesterday. Tiny little village, 2 miles up the road. A cloud computing hosting provider has just launched there, offering services to businesses around the world. It's bizarre. I hope they're not using the same network I am. These are some figures. A man called Guy Rosen has begun tracking some of the growth, some of the use of various cloud computing providers, using some figures from a company called Quantcast. Now, these are him looking at these figures and drawing an analysis from them. So they may not be entirely realistic. But what he's seeing is Amazon as number 1 and continuing to grow, Rackspace as number 2 and continuing to grow, and then a number of others, for example, Joyent and GoGrid down here, much lower, but again continuing to grow. So real growth in hosting and in use of cloud services. How long will Amazon stay number one remains to be seen. A man, Simon Wardley, who I mentioned earlier, did a presentation recently where he was looking at all these different definitions of cloud computing. He claims to have asked a taxi driver what cloud computing was, and this is what the taxi driver told him. It's like computers on the internet in it. Okay, who agrees with that? Is that what the cloud is? Few. Okay. Anyone disagree? Okay. It's actually not a bad definition for the cloud, depending upon what you mean by the internet, of course, and computers and some of the other words in the definition, but it's not a bad definition. Part of the problem with the cloud and this notion of the cloud is that it's one of those really woolly definitions. You thought Web 2.0 was bad. The cloud is possibly worse. It lumps together a whole load of different definitions, concepts, and capabilities. And people are constantly struggling, trying to decide what is in and what is not in the definition of the cloud. And that will probably go on for some time. One of the best recent efforts is probably this one from NIST in the United States. And they have a document that goes through and lists the various attributes of the cloud. But broadly, the sort of high-level takeaway is convenient, on-demand network access to a shared pool of configurable computing resources. That's not bad. And traditionally, we see this represented as this three-level stack. And again, various people have sliced and diced it slightly differently, but broadly we see this three-level stack. Infrastructure at the bottom, infrastructure as a service sometimes. So it's things like computers in other people's data centers. Amazon, Rackspace, GoGrid, and others are offering that sort of capability. Storage in other people's data centers. So probably the best known example of that is Amazon's S3. It's simply a big hard disk out there. Elasticity, this ability to scale computing resources or storage as you need it. And then bandwidth, electricity, cooling, etc. One of the big arguments in favor of this is this notion of avoiding significant capital expenditure. You're not needing to have to go out and find large amounts of money to lay down up front to buy lots of machines that you're then going to kind of trickle use over 3 or 4 or 5 years. You can scale to meet demand, and you can begin to look at various hybrid approaches as well, where that integrates with your own data center. Moving up the stack, we have this notion of platform, or platform as a service. And this is probably the least developed part of the cloud computing stack, but actually has the most potential. You can concentrate, the argument goes, on your application or your service and what it actually has to do. You don't need to worry about the low-level underlying stuff. You're simply drawing upon capabilities that someone else has provided. So Salesforce with their force.com service is one example of that. A company called Apprenda with SaaSgrid, Microsoft Azure, Google's App Engine, and others are examples of this platform that other people can begin to build upon and gain the advantage of the underlying capabilities. The least developed for now, but I think this is probably the one to watch. At the top of the stack is the part of the cloud that most people see most of the time. The software and the applications. They're mostly lightweight. They're delivered via the web. And at the moment, they're mostly what would be called a low-end disruption. They're not about replacing Oracle or replacing Microsoft Office or replacing all of Blackboard. They're about hitting the low-end stuff, the low-hanging fruit, the easy things that meet most people's needs most of the time. So Google Apps, for example. In the accounting space, Cashflow and Free Agent. WordPress, Salesforce, and others. So at the moment, mostly low-end disruption. And around all of these, and increasingly around all of these, a flow of data. As more and more applications, more and more services move to the cloud, the data follows. And some interesting things begin to happen as applications and services that were inside the enterprise, inside the firewall, begin to move out. So we're seeing examples in the commercial world, people like Reuters increasingly exposing some of their data. The data that was previously their crown jewels is increasingly being opened up and used to drive new services and new innovations. It's not making what they previously made money from free, it's about moving the value, moving the proposition, and gaining revenue in new ways. So just to finish off, the cloud and higher education. Clearly, it's an area of growing interest. At least some of you are here because of this morning's session, so you're not all sat through this just waiting for the virtual world stuff this afternoon. So there's some interest. The JISC, the Joint Information Systems Committee, has 3 calls out at the moment to try and understand various aspects of the cloud and cloud computing and what it might mean for all of us. And it will be interesting to see what those projects have to say. If you're interested in bidding, you better be quick. The deadline's the 15th of October. Amazon too, and we'll be hearing from them in a moment, but Amazon Web Services gives out funding to a number of educational projects to do interesting things with Amazon's Web Services. In their most recent announcement, only one UK university received funding, the University of Wales at Bangor. But in previous rounds, other universities such as King's, Cambridge, and Bristol have all been recipients of Amazon funding. And maybe we'll hear more about some of the things they're doing later. So that cloud computing stack that I mentioned, there are clearly opportunities at every level of that stack. Some are going to be more interesting to some of you than others. And you don't have to take the whole lot, lock, stock, and barrel, to receive the benefits that you want from the part of the stack that interests you. The kind of things you could do, virtualize some of your on-campus servers. Companies like Eli Lilly, for example, have taken this approach, virtualizing existing computing so that their research teams can gain access to cloud services far faster than they could have gained access to equipment in the past. Instead of procuring a server and waiting months for it to arrive, they're asking for exactly the server they need with exactly the software they want and having it up and running in minutes or at most a few hours. We could aggregate a lot of the data centers that we have at every institution and aggregate them regionally or nationally or just within a city and gain some of the economies of scale there. Be an interesting thing to look at how that could be made to happen. We could look increasingly at building internal software and internal applications on some of these platforms that are out there, instead of building everything from the bottom up internally. Replace existing suitable desktop software with cloud applications instead. And again, we're seeing some examples of that. And one of the easy, quick wins there, perhaps, is to get rid of the on-campus email, get rid of on-campus calendaring, and hand that out to the cloud. And clearly there are pros and cons to that. So just to finish off, Pricewaterhouse has quite an interesting series of reports called their Technology Forecast. And the most recent one of those was on cloud computing. There's some very interesting examples in there that are well worth having a look at. They talk about this evergreen IT rather than the cloud, but it is worth having a look. As with all things that are hyped, there's a suggestion that the cloud is the answer. No, of course it's not. The cloud isn't the answer. The cloud, in its broadest sense, probably doesn't exist. There are lots of clouds, and they meet lots of different needs for lots of different people. Solutions from the cloud may help you, but you need to think about what your institution actually needs. Don't embrace the cloud because it's cool. Embrace the cloud because it solves a problem you actually have. Whether that's cost, efficiency, scalability, green issues, self-service, or whatever it may be. Start off simple. So why not, for example, find that demanding research group that's banging on your door every day asking for yet another server, and tell them to use EC2 instead. And give them Simone's email address at Amazon instead of yours. See what happens. Thank you.